All right, so what do we have here? And actually I forgot to do one, so I need to get that real quick. I forgot all about this. Most of y'all don't have calculators, which is kind of a bummer. You really need to buy one or get one from the library. Although truth is, if you get one, you'll have more success with it because it'll be yours. I mean, so it makes sense to get one. It's called ownership. Anyways, given the table below, perform a quadratic regression using technology. And I'm doing this backwards for no good reason, mainly because I'm just bored. And to show you not everything has to be done from one moving forward. What we're going to do is we're going to put this information in our calculator. So that's done by hitting Stat, Edit, which is highlighted. And generally speaking, your top row is list 1 and your bottom row is list 2. You see I've got to clear some stuff out because who knows what's in there. Anyways, time to put this stuff in. Maybe. All right, so in list 1, I'm going to put in row 1. I'm sorry, I'm having like difficulties this morning. And in list 2, I'm going to put in row 2. All right. I'm going to go ahead and look at the graph. I'm going to hit second stat plot. These are on. If yours is off, which I need to remember to do when I'm done, go through that process. Second stat plot. 1, just turn them on. You'll see it's got the little dot plot set. Then zoom 9. Apparently I have something in Y1. Need to clear that out too. And that's the stat plot. And this doesn't really look like a parabola, but to some degree it is. We'll see in a minute. Perform a quadratic regression using technology. So I'm going to go to Stat, Calc, Quad Reg, which is choice 5. I'm going to do a little more than that. See where it says store regression equation? It's been a while since I've done this. I think it's under vars, y variables, function, y1. And that's going to throw the equation straight into y1 for me. Anyways, calculate. Error stat. Check the number of data points needed for the calculation. Interesting. Should have been enough data points. Oh, it's got a frequency list. Need to clear that out. There we go. Vars, y variables, function, y1. Enter. All right. Now here's my quadratic equation. Now, the reason I went through that process of doing the store regression equation is because it put that thing in y1 for me. That's why I went through that process. Write your resulting equation. Take these out to at least 4 decimal places. Some of you guys will take dual enrollment next year, and she's really particular about on these particular equations that you better do the store regression stuff for accuracy. But anyways, I say do 4 positions. That's x to the second, because it says that's what a is, plus b, which is 10.2961, plus c, which is 38.9685. And it also says interpret the r squared value to find r. So r squared is 0.8818 and some change, which means r is going to be the square root of that thing. All right, let's see what that is. Square root 0.8818, and I'm going to go farther because I can see the numbers here. 258,293, which is 0.9045 or 0.9046. Now this is a very strong coefficient. And forgive me, I am just like exhausted. Is a very strong correlation coefficient. Lots of textbooks teach this differently, but generally greater than around 0.8. Some books say 0.7, but generally greater than 0.8 is strong. And the closer you get to 1, the better off you are. And let me say it's a very strong positive correlation, because it is positive. The R value is positive. So we've got that. So this is very likely a quadratic regression. And now let's go to the calculator. We did that regression storing here. I'm just going to get the graph key because I've already looked at the plot. And here is my quadratic that's modeling this data. And it looks like it fits pretty good, actually. All right, using your equation, what x values create y values of 20? And this is another reason why I did the calculator. I'm going to go to y equals. I'm going to put a 20 in y2. I'm going to hit graph. And I'm going to use the intersect feature. Second trace 5 for intersect. This is exactly the way your dual enrollment teacher will teach you next year. Enter, enter, enter. And there's your intersection, 1.1331. Ta-da! There we go. There's 20. All right, preceding this one, which is number 18. I don't know what happened to number 19. A domestic terrorist rolls a tree that is 55 foot in height, standing 12 foot from the center of the tree. And throwing the TP roll from an initial height of 2 foot, the roll clears the tree by 1 foot and lands on the other side. This is actually a very impressive throw. I don't know how good your TPing skills are, but this guy is a master. So we have a tree. There's my tree. We got our little domestic terrorist here. He's angry about something. There's his roll of toilet paper. He's apparently going to underhand this thing. It's going to go over the tree and land on the other side. We're going to put his roll of toilet paper at the origin. So what we're doing here is we're superimposing the XY axis on this thing. So this is the point 0, 0. He is 12 feet from the center of the tree, so the tree center is going to be at 12, 0. And the roll clears the tree by a foot and lands on the other side. I need to add some text into this. I really do. But we'll just use symmetry here. Let's assume that he's a foot from the tree. Yeah, we'll just call this 24, 0. Really should have used some numbers there that made more sense. Missing something in the text. But anyway, it's 24, 0. The tree is 55 foot tall, and he clears the tree by 1 foot. So here we would be at 12 for x, 56 for y. The roll of toilet paper is at 0, 2, because it has an initial height of 2 foot. And now we write an equation in vertex form that models this rat, this random act of terrorism. Vertex form is y equals a times x minus h, quantity squared plus a k. And I can do a little substitution here. Y is a, here's my vertex at 1256, so x minus 12, quantity squared plus 56. Now I need to figure out what a is. I can do that by plugging in a point, and I have a really, really good point here. That point gives me an x and a y, so I'm just going to plug in. So y is 2 when x is 0. Now, if you take a 12 and square it, you get 144. If you add 56 to 144, you get 200. So, I'm sorry, that's wrong. You have 144 a's plus 56, and that's equal to 2. We're going to subtract the 56. 2 minus 56 is negative 54, and that's equal to 144 a's. And we're just going to divide both sides by 144. And obviously, we're going to simplify the fraction. That's negative 27 over 72, which I think you can do better than. Those are both divisible by 3, I believe. Which is going to be negative 9 over what? 24? Yeah. Negative 9 24ths. So here's your equation. Y is negative 9 24ths of x minus 12, quantity squared, plus k, which was 56. Part 2 is to convert it into standard form. So you're going to have to write out, this is, by the way, is the answer to part 1. Part 2, you're going to have to write this thing twice, because you're going to square it. Then you can do the FOIL technique. X times x is x squared, minus 12x minus 12x minus 24x, plus 144, and then add 56. Then you could do the distributive property, because, why could this be so easy, right? Let's see, we'll have negative 9 24ths of x squared. Here, the 24s cancel. So we're going to have plus 9x. Hopefully you understand that, the 24s cancel. And let's see here. I feel like this ought to be negative 54, but I'm tired. Like, it makes sense that I'm going to get back a negative 54 here, but who knows? Should. That's exactly what I'm going to get back. I don't need a calculator for that. That times that's minus 54. Add your 56. And you get negative 9 24ths of x squared plus 9x plus 2. See that 2? It's that 2 right there, the y-intercept. All right, determine where the roll of TP hits the ground. It says you'll probably need the quadratic formula, and you probably will, because the equation we wrote is pretty ugly. But there might be an easier way. And I feel like there is an easier way. And yes, there definitely is an easier way to do this other than the quadratic formula. Your roll of toilet paper hits the ground when y is 0. And I've got this equation right here that I'm going to use. It was negative 9 24ths of x minus 12, quantity squared plus 56. This is going to be easier than doing the quadratic formula. You can take away your 56. Negative 56 equals negative 9 24ths of x minus 12, quantity squared. We're going to divide both sides by negative 9 24ths. I've got a calculator, so I'm not going to worry about doing this one by hand. Plus, I don't want it to take all day. There we go, she's on. Oh, by the way, you should turn stat plots off. when you're done. Forgot to do that. We're taking a negative 56. We're dividing it by parentheses because they matter. Negative 9/24. Something that's not very pretty. 448 over 3 is equal to x minus 12 quantity squared. Now there's no way I'm going to be able to make this thing look pretty. I'm going to take the square root of both sides. I'm going to get that number. 12.2202 is actually plus or minus 12.2202, right? Is equal to x minus 12, and I'm going to add 12 to both sides. So 12 plus or minus 12.2202. Now, if I do the minus thing, if I do 12 minus that, I get that one time is negative 0.2202, which doesn't make a lick of sense. That's extraneous. And the other time is going to be 24.2202. A 24-second throw of toilet paper. That is incredibly impressive. Now, something a lot of teachers teach, and I probably should too from time to time, is just using Desmos. You know, there's been a bigger push to get technology more involved. And as much as I'm against it, it kind of makes sense. So this was, equation was negative 9/24. You can just type the thing in Desmos. X minus 12, if you can type quantity squared, plus 56. And you want to know when the toilet paper hit the ground. Well, that'd be right here, wouldn't it? Desmos is apparently, it's really hard to get on the zero. Yeah, there it is, 24.2202, which is exactly what I came up with by hand. So if you don't believe whatever I'm doing, there you go. Moving backwards. Now let's do 16. A parabola has a y-intercept of 0, -6, and a vertex at 2, 3. Write the vertex form. You can just plug into this guy. That's h, and that's k. So y is a times x minus 2 quantity squared plus a 3. And then we're going to plug in this stuff right here. -6 equals a times 0 minus 2 quantity squared plus 3. A -2 squared is 4. So -6 equals 4a plus 3. Don't be the kid that adds 4 and 3. 4 is attached to the a. We take away 3, we get -9. And we divide by 4, and we get -9/4. And all we got to do is put that right there, and we're done. Y is -9/4 of x minus 2 quantity squared add a 3. And moving backwards, convert things into standard form, which is really easy. I did one of these earlier. All you do is you write something twice. And then do FOIL. So x times x is x squared, times 3 is plus 3x, plus 3x, plus 9. And all that has a -2 out front. Notice how I did the FOIL operation first. I didn't want to double x plus 3. It would have made it harder. Use the distributive property. There's going to be 6x here, so times a -2 is -12x. And lastly, combine like terms. Those guys are alike. That's -26 when you put them together. And converting to standard form, pretty simple. Moving backwards again. Person is wishing to fence in their backyard because their dog keeps biting the mailman. They are flat broke but happen to know an individual with 500 foot of fencing available free. They intend to use their house as one side of the fence. What is the maximum area they may enclose? So here you have their house, and they're building a fence. And they don't need fencing along the house. The house functions as a fence. I want to know the maximum area. Area of a rectangle is length times width. And when you think about this thing, it's perimeter because you're involving the house. So the perimeter of this figure is not 2 lengths plus 2 widths. It's 2 widths plus a length. And I happen to know that that perimeter has to be 500. So 500 is 2 widths plus a length. What I'm going to do is I'm just going to solve this thing for the length. 500 minus 2w is my length. And then I can use the substitution property. I can put that right there. So the area of their fenced-in backyard is going to be 500 minus 2w times a w, which is going to be 500w minus 2w squared, which in STD form is negative 2w squared plus 500w. Now, why am I doing that? Because I know how to find a maximum. This is a quadratic. The max happens at opposite b over twice a. So the w value, the width value here, is going to be negative 500 over twice a negative 2. So that's going to end up being 500 over 4, which is 125. I'm going to go back to my diagram, 125, 125. That makes 250, which means the length is 250. Because 500 minus 125 minus 125 is 250. And so the area of my rectangle then is going to be 250 times 125, which ought to be on up there. Sometimes it's just quicker to do things in your head. I already have the answer. I just don't want to pull something out of thin air here. There we go. 250 times 125. $31,250. That'd be what, square feet? $31,250 square feet. All right, I've done all the hard ones so far. Let's see here. Let's do the Soviet Russia. Now, this is not true, I think. Although the Soviets, especially under Stalin, were pretty brutal. In the old Soviet Russia, failing students were launched from catapults to encourage, now they just throw people out of windows, to encourage future engineers to comprehend quadratic equations. The path of a failing student would be parabolic in nature, and the height of a student at time t could be modeled by the quadratic equation in the form height as a function of time is negative 16 times squared plus a, it's supposed to say subscript 0 of t, plus h subscript 0, blah, blah, blah. An equation modeling the death of this poor failing soul. This guy has an initial velocity or acceleration of 192 feet per second. I called it y. Height is a function of time is negative 16t squared plus 192t plus the initial height of 10. Find the maximum height achieved that happens at the vertex. This gives me the time, not the height, but the time of maximum height is going to be opposite b over 2a, which is going to be negative 192 over twice a negative 16. And I believe that's 6. Yeah, it is. So 6 seconds. Now, if I actually want to know the height, I'm going to find the height of 6 seconds by taking that 6 and plugging it in. I'm just going to push some buttons on that. We've got a negative 16 times a 6 that's squared plus 192 times a 6, add 10. 586 foot in the air. This this failing kid's gone. You ain't coming back from that. And fear is a good tactic. I guarantee you that if you saw this happen to a kid who was flunking class, you'd probably try harder. Now, wouldn't you? And you'd also fear Big Brother. Term when the individual goes splat, says you're probably going to use the quadratic formula. You're going to go splat whenever you hit the ground. And this kid was up there. This student, this could have been like a college kid. Anyways, this individual is going to go splat. That's not going to factor. I mean, we could pull some numbers to make it smaller, like I could pull a 2 from everything, but it's not going to factor. I don't think it does. We'll find out if we do the quadratic formula. We'll just sing x equals negative b plus or minus square root b squared minus 4ac all over 2a. We'll just plug some stuff in. So opposite of 192 is negative 192 plus or minus the square root of 192 quantity squared minus 4 times negative 16 times 10. All sitting pretty over twice a negative 16. So I'm going to evaluate the discriminant in my calculator first. The discriminant was 192 squared minus 4 times a negative 16 times a 10, which is 37,504. And both these pieces are sitting over negative 32. Now let's see what we get here. We have the negative 192 minus that square root divided by the negative 32. So I have a time of about 12.05 seconds. What's the other one going to be? That was the minus operation. I highlighted, I pressed enter. I'll change that minus into a plus. My emulator is very slow today. Probably have too much stuff open in the background. And when I divide this one by negative 32, I'm going to get a funny answer. My other time is negative 0.05. And this, by the way, is that extraneous answer. It doesn't make any sense. 12 seconds in the air. That's an eternity if you're the one in the air. Let's see, I don't feel like doing a John Deere Company one. Let's do a little trig. So I'm going to do number 8. Let's see, you're given the tangent ratio and you're supposed to find the sine ratio. Now, by and large, the trig you see on the ACT is first quadrant trigonometry. So I'm going to draw a triangle in the first quadrant. I'm going to put angle A right there in the corner. And the tangent of A is root 5 over 2. And, you know, you're expected to memorize SOHCAHTOA. Like, you're expected to be able to do SOHCAHTOA. Like, it's not hard. The only thing that's hard about it is your head. Anyways, the tangent of an angle, and this one's called A, is going to be the opposite side over the adjacent side. And this would be the O, and this would be the A. So opposite of A is a root 5, and adjacent is a 2. Now, I'm tasked with finding the sine, and sine is opposite over hypotenuse. And you'll notice that's what you don't have. So you got to do a little Pythagorean theorem to figure out the hypotenuse. And it's not hard. So we do a little a squared plus b squared equals c squared. 2 and root 5. you take a square root and you square it, they cancel each other out. That's just 5, and 2 squared is 4. 4 and 5 makes 9. And hopefully you know that the square root of 9 is 3. If you don't, may the Lord have mercy upon your soul. Anyways, I did all that to get the hypotenuse because I already had the opposite side is root 5 and the hypotenuse is 3. So the answer is root 5 over 3. So katoa, kids. It's easy. Determine what transformations have occurred to the mother function f of x equals x squared for each given equation by converting it to f of x equals a times x minus h quantity squared plus k vertex form. All right, so we're going to replace f of x with y. What we're going to do is we're going to do the complete the square technique. We're going to divide everything by -2. We're going to move this over here. We're going to take half of b, and b is 18. We're going to cut it in half. You're going to get 9. We're going to take that 9, we're going to square it and get 81. And we're going to add that to both sides. And I forgot to write +4 here, didn't I? And that's not part of the fraction. I have to add 81 to both sides. This is a perfect square. We did this lesson Monday. That's x plus 9 quantity squared. And I can start moving things around again. 4 and 81 makes 85. I can move this back over. Y over -2 equals x plus 9 quantity squared minus 85. And the opposite of dividing by -2 is going to be to multiply by -2. And if you do it to the left, you do it to the right. So I have -2 times x plus 9 quantity squared. Negative times a negative is a positive, plus 170. I almost wrote 190. These are going to be pretty tricky for a lot of kids. I know they are. It's just how they are. But now I can talk about the transformations that happened, what transformations did happen. We went left 9 units. We have a horizontal shift. Man, I can't type. Left 9. We have a vertical shift. We went up 170. Wouldn't have guessed it by looking at that thing. I guess it doesn't have any, well, it's got x-intercepts. What else do we have going on here? We have been vertically reflected from that negative symbol. It's a vertical reflection, not an x-axis reflection. Vertical reflection. And we are twice as steep. We call that a vertical stretch. That comes from that 2, which changes the slope. It's twice as steep or half as, well, probably a quarter as wide. All right, I'm getting there. I guess I'll do 4. You're supposed to find some things. You're supposed to find the vertex, the y-intercept, and blah, blah, blah. So your vertex, the x-coordinate is at opposite b over 2a. So opposite of a +4 is a -4 over twice a -1. And that's going to be -4 over -2, which is 2. So x is 2. To find the y-coordinate, we plug that in. See, we have a negative symbol. That's going to become -4. That's 8. 8 minus 4 is 4. Minus 3 is 1. Our vertex is at 2, 1, right there, sitting pretty. For your y-intercept, you let x equal 0. So y is going to be -0 squared plus 4 zeros minus a 3, and that's just going to be the negative 3. In standard form, that last number is your y-intercept. 0, negative 3. It's going to put it right there. This is also where this, by the way, is the axis of symmetry. The axis of symmetry is at x equals 2. And if I have a point 2 units to its left, I have another point 2 units to its right, and that would be at 4, negative 3. Congratulations, you have the 3 points required to draw a parabola. Her domain is negative infinity to infinity. She runs right and left forever. Her range is negative infinity to 1. Bracket on the 1, because it is a valid point. That one did not factor. That's why I didn't talk about factoring, because your instruction set says if it factors, factors. I'm going to do 1 because 1 actually does factor. It factors as x times x minus 2. So I actually have two intercepts here. I have an x-intercept at 0, and I have an x-intercept at 2. It's cool. By the way, on an x-intercept, the y value is 0. There's 2 points in your table already. And you probably would have come up with these with symmetry anyways. You would have. All right, let's see here. Let's go back to standard form. Let's talk about our vertex. Again, she's at opposite b over twice a. You should write that a few thousand times. Opposite of a negative 2 is a positive 2. A is the understood 1 in front of x squared. And you get 1, which is cool. To find the y corner of the vertex, you take that 1 and you plug that 1 in. 1 squared is 1, take away 2, and you get a negative 1. So the point 1, negative 1 exists. Be right there. Now, we've already got the next point because the y-intercept, we let x be 0. So y would be a 0 squared minus twice a 0, which is 0. So we already have that. Your axis of symmetry passes right through the vertex. Its equation is x equals 1. We already got both points by factoring ahead of time. Domain is negative infinity to infinity. All parabolas are. The range has a low value of negative 1, and it rises to a high value of infinity. And that is half of your homework. Now you do the other half.